Okay, Pre-Calc 5.3a, section 5.3a, and we are going to be solving trigonometric equations. So we're going to break this into two sections, and the first one is going to be about solving them using the algebraic techniques. The second one, we'll talk about how we can use trig identities to solve, but that's kind of what we're going to work with. All right, I think this section is easier than the previous one, so if you're really struggling with the identities and simplifying things like that, this one will be, I think, a little bit better. Okay, so just kind of going through some techniques to solve trig equations, and you can pause or rewind this so I can go fast through it. Solve a trig equation that involves only one trig expression. We want to begin by isolating this expression. So if you can get that trig function on one side of the equal sign, that helps. Okay, when you're taking square root, okay, you remember you have to consider both positive and negative values. All right, when they cannot be combined on one side, try to factor. So factoring is an option as well when you can't combine them on one side. We could just kind of like algebra, just using algebraic techniques to do this, and then the zero product property. Okay, remember what that is. When you get your factors, set them equal to 0 and solve. Okay, if the equation has a quadratic form, if it's in a quadratic, try to factor it if you can. That's always the first check. And remember, just like in the past with non-trig stuff, if you couldn't factor it, you can always use the quadratic formula. Okay. And then once you've got your answer, we look at our radians and find the radian measure. So you might need your unit circle notes here to kind of help you there. To get those values if you haven't memorized it yet. Okay. Or another thing would be like your exact trig values, those notes, because of basically tangents, the one, right, that it just kind of helps to have your exact value notes rather than the unit circle. You can do it from the unit circle, but remember you have to divide y by x. Okay, and then if you have a restricted domain, obviously state only the exact values. And then solutions on this interval here from negative infinity to positive infinity are found by adding integer multiples of the function's period value. Okay, so kind of say that, and then we'll kind of talk about what that means here. So we look at that, we can say when we're talking, if the function you're talking about is sine, cosine, secant, or cosecant. Remember, when we graph those periods were 2 pi, and for tangent and cotangent, those periods were pi. Okay, so this part right here, I'm just going to kind of circle it. Okay, remember that part here is going to give your answers a different look. Okay, so you're going to have like an answer that looks like this. Okay, your solutions will be, x equals, let's say, for example, let's say you got pi over 3 was your answer. Then we would say, well, if it's, sine, cosine, secant, or cosecant, it would be pi thirds plus 2n pi. And there might be another one as well where you have x equals 5 pi over 3 plus 2n pi, and then you'd have to have n exist as an integer. N is an integer. Okay, so that's where we come up with this integer multiples. So your answers are going to kind of take that form. You're going to have your exact values, but then you have to add the multiples of the period. Okay, so if we're talking about sine and cosine, it's 2 pi, but if your function is tangent or cotangent, it would be pi because those periods are just pi. All right, so let's go ahead and start solving and see how we do with this. Okay, all right, the first one. So we've got this expression or this equation. So I want to isolate this thing and get those cosines on the same side. Okay, so I'm going to do that by just doing algebra, and I'm going to subtract 5 cosine x from both sides. Okay, so now on the left side, I'm going to have 0 because those cancel out, and then I'm going to have, well, 3 minus 5 is negative 2 cosine x plus the square root of 3. So I got the cosines to one side. Now I've got to bring this to the other side. I got to bring this, I want to isolate it, so I'm going to bring square root of 3 to the other side. So now I am left with negative square root of 3 equals negative 2 cosine of x. And then just keeping with that idea is I'm going to just keep going here. So I'm going to subtract negative 2, just doing my algebra, not subtract, sorry, divide by negative 2. And so now what I have is when those cancel, I'm going to have cosine x equals square root of 3 over 2, because those two negatives will make it a positive. Okay, so I've got cosine x equals square root of 3 over 2. And so now I look at the unit circle and I say, all right, well, where are those values? Okay, so what values is cosine at square root of 3 over 2? So when I look at that, I can see that at pi over 6, I have square root of 3 over 2. So I'm looking again at my x coordinates on the unit circle. Okay, so pi over 6 would be 1, but I'd also say plus, since we're talking cosine, the period is 2 pi plus 2n pi. And there's also another value where you have 11 pi over 6 is also square root of 3 over 2. So I have 11 pi over 6 plus 2n pi as well, because every rotation of that circle, every 2 pi, it would repeat. And then I just have to put, again, another comma, that n is an integer. Okay, so n exists in z, or z set. So that would be our final answer there. Okay, let's do another one. Let's do number 2 here, just using algebra again. So my first step here is I'm going to take this and I'm going to try to isolate that trig function. So I'm going to add 4 to both sides. So I have 3 tangent squared x equals positive 1. Okay, now next thing, right, is to divide. So I'm going to divide by 3 on both sides. So now I'm going to be left with tangent squared x equals 1/3. Okay, so I have a square. So how do I undo that square? I'm going to take the square root of that. So I do that, square root of both sides. So now I have tangent of x equals the square root of 1/3. But remember, we got to consider both positives and negatives. Square root of 1/3. Okay, which is also equal to, well, we'll just kind of, square root of 1 is 1, and then you have square root of 3 on the bottom. But remember, you can't have a radical on the bottom, so you have to rationalize this. Eventually, you'll get to that square root of 3 over 3. Okay, so that's not our answer, though. Remember, we're going to write our answer in this form like this one here. So I have to look at where is tangent square root of 3 over 3. Well, it happens to occur at a few places. So x would equal pi over 6 is where tangent is square root of 3 over 3. But now notice I'm going to write n times pi because this period, we're talking tangent. So the period is only pi. Okay. Are there other places that it happens? Sure. There's one more, and it's 5 pi over 6. And again, plus n times pi. And I just have to make a note that n is an integer. Okay. So at those 2 places for sure, and then every period, so n times pi, those would repeat. That's where tangent's going to be square root of 3 over 3. So solving those that way. Okay. Let's do 2 more, because it just added show some different techniques on how to do it. Okay. Now this one says find all solutions on each interval 0 to 2 pi. Okay. So same idea. I'm just going to try to isolate here. And now I have, two functions. So this is where, I might have to do some separate things. Might have to factor. So let's start by getting it to one side, isolating it, setting it equal to 0. So I'm going to do that by subtracting the square root of 3 sine x. I'm going to take this whole thing to the other side. So now I'm going to have 2 sine x cosine x, because that didn't go anywhere, minus the square root of 3 sine x equals 0. All right, next is, so now can I factor something out? Well, yeah, I can, because they both have a sine x in them. So I'm going to factor out a sine x. And now I've got 2 cosine x in that first term. And then I have minus the square root of 3 in the second term. So I'm just kind of doing some factoring out the sine x. And now I got to kind of take both terms, right, and set them equal to 0. So this part here, sine of x equals 0. And then over here, I'm going to do the same thing. 2 cosine x minus the square root of 3 equals 0. And I got to solve both of those as we go. So the first one's pretty easy. I'm just looking at where is sine of x equal to 0. So I'm looking on my unit circle, and we're talking sine. So I'm looking on from 2 pi, where is sine of x 0? And it happens twice, right? It's going to be x equals 0 and pi is where that happens, okay? And then from this one, I'm going to take, you've got to obviously add the square root of 3 to both sides. So then, as I'm solving this one, 2 cosine x equals the square root of 3. And then I'm going to divide by 2, right? So cosine x equals square root of 3 divided by 2. Okay, so where is that on our intervals? So we know we have x equals, well, that happens a couple times as well. It happens at pi over 6, and it also happens at 11 pi over 6. Okay, so now I don't have to add that n times pi or n times 2 pi in case of sine and cosine, because I don't have to add that in my answer, because it already says here, I'm just looking at this interval 0 to 2 pi. So how many times does that occur from 0 to 2 pi do we have a solution? And so I've got to put these values and these values. So my final answer would be 0, pi over 6. I'm just going in order, numerical order, pi, and then 11 pi over 6 would be all of those values in which I get a solution. Okay? All right, let's try one more. This one's the trickiest one because you kind of have to factor. It's like in binomial form. Or you can factor it binomially with it is trinomial. So let's start here. So it's already equal to 0. So we're good there. So now I'm just trying to factor this out. So I've got to find a way to do this. And so I just I'm going to make my parentheses and kind of reverse FOIL, right? Which is factoring. I have 0 over here. So if I put this in and I go 2 sine of x minus 1, and then sine of x plus 1, that should do it. And remember, you can always look and check by just foiling this. What would 2 sine times sine be? 2 sine squared. Okay. How about my outside terms and inside terms? I go 2 sine times 1 would be 2 sine. And then I have a negative 1 sine. That would give me 2 minus 1 is positive 1 sine x. And then my last terms, negative 1 times 1 is the negative 1. So it checks out. If you're unsure, you can always go back and check your work by foiling. Okay, so now I have my factors. So same thing. Now I'm just going to set each of these factors equal to 0. So this one here, 2 sine x minus 1 equals 0. So let's go ahead and solve that one. I'm going to add 1 to both sides, so 2 sine x equals 1, and then sine of x would equal 1/2 then. So now I'm looking at what values, and I can use my unit circle notes, right? I can look at what values is the sine of x 1/2. So my y-coordinates is what I'm looking at on the unit circle. Turns out pi over 6 and 5 pi over 6 are those solutions there. How about the other one? So this one here, sine of x plus 1 equals 0. So I'm going to subtract 1, so sine of x equals -1. And now I look on that, what value? So I'm looking at my y-coordinates. What value do I get a y-coordinate of -1? Only happens once. It happens at 3 pi over 2. So now I've got my 3 solutions. They would be pi over 6, 5 pi over 6, and 3 pi over 2. And remember, I don't have to have the plus 2n pi because it already tells me in the problem that I'm looking at this interval 0 to 2 pi. So I'm just looking at one full period, one full rotation in that circle that get my answers there. Okay? That is it. Short and sweet.